Yo, what's up everyone? This is the part 3 of the rotational dynamics series, and today we are dealing with some most repeated short questions. This is a short video, so let me just end it quickly. So the first question is, if the size of Earth is reduced to half of its original size, what happens to the So in this question, what you need to answer is, you can write the language, but you can just say, from conservation of angular momentum. That is why I said this is very important. This is the most important part of this chapter. We know that I omega is equal to constant. That means omega can be written as 2 pi by t, which is constant. So from this, t goes the other side. So I will be directly proportional to the t, or I will be t divided by the t is directly proportional, so the moment of inertia is directly proportional to t, or mr square. Moment of inertia is mr square, is directly proportional to t. So what you need to understand here is m1r1 square by m2r2 square equal to t1 by t2. This is what happens. So when there is nothing given about the mass of the earth, we assume that the mass will remain the same, so we can cut this. So the radius is half, r2 is half of r1 equal to t1 by t2. So if you do this, this will be 4, and it will be 4 times. So 4 times, this will cut off 4 times wait a minute. T2 will be equal to T1. That is, T2 decreases by 4 times. Just like that, you can answer that. Now question number 2, it says, if Earth is struck by meteoroids, it will slow down. Why? We know that from the conservation of angular momentum, we know that I omega equal to constant. That is, I is proportional to 1 by omega. So if Earth is struck, I will increase. Therefore, its angular decrease. Why that happens is the distribution of mass changes. That means also mass and the distribution of mass both increases. Now we have number 3, the ice at polar caps of earth melts and time period of earth is affected. How? This is the exact same question to same as number 2. Just the difference is there both mass and distribution changed, but here only the distribution changed. You might include this in the answer, but you may not as well. So that's it. Question number 4, if you move on, then it says a man standing on a rotating table extends his hand. Suddenly what happens? A man standing in a rotating table extends his hands. What happens? Another question is a ballet dancer extends herself. What happens? These both questions can be also answered similarly in question number 2 and 3. The thing is the distribution of mass. You just start with I omega equal to constant, and then I will be proportional to like this, and then when they either extend their hands, the I increases, and or the ballet dancer extends herself if the I increases, or vice versa, it decreases when they lower the hand. So you can answer it accordingly. I'm not going to answer that. Now we have the last type of question, and that is why is range of longer arm and why is in one side of these both can be answered by the definition of torque, which is Fr sine theta or Fr. So torque is directly proportional to R. So if radius is increased, force torque is more. So easier work is done. That's how we answer it. And that is pretty much it with the last question, question number 8. Why is it easier to open bottle cap with 2 fingers? Okay, that is very simple, because on doing so, couple force act. Two fingers at different line of action produce more torque. And you can just draw this diagram just like this, and like this. This should be opposite. This is more. Practical demo right here is while I open this pen's bottom needle just like this. If I try to open it with one finger, it is quite difficult. It will open, but it is quite difficult. But if I use couple forces or 2 forces just like this, it is too efficient and too easy for me to open it. Similarly, while closing it, if I use one finger, it is kind of difficult. It takes more force. But if I use 2 fingers, it is more easy. In that way, you can explain the use of couple in this. That is it for today's video. We will be doing the numericals in the next video. Thanks, bro.